Thank you. Thank you, thank you. I want to manage the expectation. I'm not going to show anything about AI into this presentation, so just to make it clear. And instead, I'm going to talk how we are evolving Nextflow from a workflow engine into an ecosystem of component technology that allows us to deploy pipeline and scale different infrastructure. So, but always maintaining the core principle of this technology, the vision that we Nextflow essentially. So to make it possible to have portable and reproducible pipeline that can be deployed without changing your code in different infrastructure, like I was saying, but also make it possible to have this pipeline scalable and efficient, because already here there is a natural tension between portability and efficiency, because it would be much simpler that you have pipeline running just a specific platform in terms of scalability and efficiency. So we want to combine these two aspects together. And also, more and more, we want to focus also to provide a solid foundation for running data pipelines, but also in a safe manner, because it's more and more important to have Nextflow running into industries, so there is more importance for this point of view to have to comply with security standards. So we have an ecosystem foundational technology, as Evan was mentioning, and three main components, which we are building on top platform, Studio, EI, and everything. So Wave is our component to deploy a container at scale, and also to provision container in our data pipelines. The point is why we need a specific service to manage container in data pipelines. Because in the early days, we were just using maybe just a container for each pipeline. It was very simple. You create the container, upload there, and run this pipeline. But now pipelines are more complex. We have many containers in the pipeline. Each task uses its own container. We have different formats, Singularity, Docker. We want to deploy in different infrastructure. Also, different CPU architecture are Intel. So for each of them, you need to create different containers. So this is an incredible complex task. You can have hundreds of these, even if you have a collection of pipelines. So managing manually is a lot of work. You should build, upload, manage the authentication, then the security. So this is all stuff we want to hide. And ideally, we want to delegate to Nextflow itself, because it can automate all these tasks through Wave. And just a reminder, so Wave has these two main operational modes. The ability to create ephemeral container just in time during the pipeline execution using your own container, but Wave allows you to extend the container with the script of the pipeline, the script that are needed by the task, the pipeline, and also infrastructural tools like Fusion, for example. Or another modality is this idea to have durable container that is instead more similar to normal containers that are built on demand during the pipeline execution and are stored into your own registry. So you have control over this. You create traditional containers that are permanent, stored in your registry. Along with this, we have added this idea of Seqera container that essentially is a beautiful front end, also we have seen this morning, that allows the community to create container on demand, just selecting Conda packages, and we then store into a public registry that is accessible by the community, and make much more simple to keep all these containers. A few numbers about the technology. Since we launched Seqera container 6 months ago, now we are hosting 4,000 container images for the sake of the community. And then we provision up to 100,000 containers per day and serve 1 million container requests per day. So we are very happy to see growing adoption of the technology. And I want to focus a bit more on this idea of pipeline portability. That is a very key idea in all the stack, and Wave also, why Wave is playing a crucial point into this idea. Because allows you essentially to create this container in an on-demand manner so that you can decide and deliver the pipeline depending where you are running the pipeline. This morning we have seen this beautiful presentation by Graviton that provide a more efficient way to run pipeline into the cloud. And And so here, this benchmark there summarizes the key figure, but I don't want to spend time over this, but more how we make this possible. So again, Nextflow to run on Graviton has no problem because run on top of Java, Java can run on Graviton. It's not the problem. The problem are all the tasks, all the tools that you have in your pipeline, and they need to be recompiled for that CPU architecture. This means that you need to recreate the container. Instead, what we can do is use Conda plus Wave to create this container because Conda already provides a lot of packages already supporting Graviton. So the idea is that you just define the dependencies of the task in your pipeline using a Conda package. So this can run just using Conda or with containers that are created by Wave using this Conda package on demand because you specify you want to use Wave, the strategy Conda, and Wave takes care to deliver this container while the pipeline is executing. Want to run this on ARM, you add a specification that you want this for ARM64. And again, Wave takes care to create the container using that Conda packages matching that platform. So this dramatically simplify all the process. It is also how we run this benchmark that was shown this morning. What's new into Wave? There are some improvement into the build capability of the tool. Also, Evan was showing this morning. Now, Wave use build kit, that is the same component also used by Docker to build the container, so we improve the interoperability of the container created by this system. Also, we are improving this page with more metadata, and also was mentioned the ability to produce the Conda log file. Let's just have a look on fly. How does it work? Here there is the Seqera container landing page. I can pick any tool that I need in my container, and then I get my container. And here I can jump into the details. Then I have the Wave build page where there is the metadata, the format, when it was created, the security scan, the log, the container file, the Conda environment file that was used to create the container, so you can trace all the life cycle of this container, and the Conda file that was mentioned before. This is nice because it allows us to recreate this container content, because here there is the precise resolution, each single package that is needed to recreate this environment if you need to recreate without using the container in another environment, whatever. Also, there is this new inspect capability. This kind of allows you to go into the container to see all the metadata. This kind of nerd view, but in some cases it can be interesting to see the low-level details, the different layers, to compare also different containers. Also, what we have added to the build is a build history view. If the container is recreated over time, you can follow all the history of this container, so I keep under control so the different version of the container that you can have. But let's look also about what there is new in Wave. There is new container mirroring capability. That means that essentially Wave can be used to copy container from one registry to another. This can be useful when you deploy the pipeline across different cloud regions or across different cloud vendors to keep the container where the pipeline is running. So this can be better to improve the efficiency because you cache the container in the same region where the computation happens, but also for regulatory reasons. It may be required that you keep the container there. So how does it work? You can use this from the command line, but of course also using Nextflow. You need the latest version on the Wave command line tool. If you want to use the command line, what you can do is Wave, for example, you want to copy a container that is Ubuntu 24.10, oops, not this, and you want to mirror it to another repository, be it repo, B2, let's try to be a large screen, cr.seqera.io. We want to copy this in our registry. This is enough to create this new container, also super fast because this was done in precedence, so we keep also the caching of this container. But the most interesting part, when you join this with Nextflow, because this is not the real deal. The real deal, when you have a pipeline with many containers, you want to move all the containers to another region. So what you can do, you can use the Nextflow configuration file. Here you enable wave, enable. I should use the autocomplete, but maybe later we can use it. With mirror, true. And then we need to specify, again, build, repository. CR Seqera.io. Nice. Now, if I do Nextflow inspect, usually this pipeline use a container. I inspect, everything seek, and if this is a pipeline that I usually use for demoing purpose, there's a container that is hosted on docker.io. But if I do now, since I changed this, it's going to use the container that is copied into our registry. And then I could run, like as usual, using the Nextflow run command. And so this is useful when you have many containers, as I was saying, and then to automatically keep in sync in different registries, depending where you are deploying your pipeline. Jumping back in the deck, what there is also new about this. We have also a new improved capability for scanning container. We was already able to run a security scan using an open source tool, this Aqua Trivi, for the container that was built by Wave. But in our pipeline, we can use also containers that are not built by Wave. And above all, there was no direct link between the security scan and the execution of the pipeline. Usually with this happen that, okay, you have the security scan, but then you don't know if there are vulnerability, you just continue to use this pipeline using that container without being aware that the container has some problem. So the idea is that now we can scan any container used by your pipeline, and you can decide to use Nextflow also to check the result of the security scan so that prevent the execution of the pipeline if there is some problem into the container. How does it work? Also here you can use the command line to check this, but more useful when using Nextflow. With the command line you could say image Ubuntu again 2410 and then scan mode required. And then await, because I want to await the completion of the scan, and I want to use YAML to see the output. And this, again, super fast because we cache this scan. Here there is no problem because this image is clean. But let's see if I use another container, a bit older. Here there is a vulnerability, this medium. And here there is the link to go into the report to see what's wrong with this container. There is this CV, so here then you can decide, okay, I want to fix this problem, I want to fix this, this issue, or change container, or whatever. But let's see, when we put together with Nextflow, I can enable the scanning with wave scan mode required. And this is enough now that Nextflow use wave to check the vulnerability of each container and decide if run a task or not. If I back here, run this, now we see we found a problem because in this container there are some vulnerability. Installing wave provisioning for container RNA-seq NF did not complete because the scan operation found one or more vulnerability. And again, there is the scan report, and then you can jump into this page to see the problem, decide, okay, I will change container, I will fix this container, and so on. In some cases, you may decide, okay, this is not a big problem. You may want to continue to use this container because you feel that it's not a real security problem. And so to avoid that, you can do scan allowed levels. For example, say that I'm fine using containers that have low or medium vulnerability. And okay, this basically give an idea how we can use now Nextflow with Wave to keep under control all the security container. And above all, one important thing, usually what's broken with the security scan? We create a container, then upload in the registry, maybe automatically there is a security scan, and then, okay, maybe there are no security issue today, but tomorrow maybe there is a new vulnerability or next week. So this change over time, but usually you don't take care or you don't have time to continue to scan this container. Instead, what is happening now with this mechanism, we keep the cache for a few days, and then, so if I run now, this is not executed, but if I run this next week, I get a new security scan. So you have the possibility to keep under control the security of the container over time, essentially. Okay, and this concludes what's new in Wave. Let's jump into the Nextflow section, this presentation that is the pillar of our technology. We just released Nextflow 2410 this week with a bunch of new capability. One of these is the support for Wave, I just mentioned, so there is not much to add here. And also, what there is new, we have the capability, the possibility to have better control in the manifest of the pipeline configuration to add more information about the contributors of a specific pipeline with the maintainer, with the author, etc. So this gives you a better fine control on this kind of metadata that is also compatible with BCO provenance format. Another nice improvement is the capability to have access to the run traces of the task. So you know that Nextflow, when run, collect a lot of information about the task, how much CPU was used, how much memory, I/O, etc. But there was no way to access during the pipeline execution. Instead, now we have the support, the possibility to access the information, the previous task execution trace record, so that when there is a failure and you want to retry the task execution, you have access to the information. This basically makes it possible to have finer control on the allocation of the memory or other resource requirement that you may want to have into your pipeline. Then what's next? Workflow output definition. This is instead, we are redesigning how Nextflow produce the output, how you define the output structuring into your pipeline. This is a second review because we are taking seriously this new model to move away from this published tier directive, something that is more structured, but at the same time also more declarative, and enable the modularization of the pipeline. What is changing to this review, essentially the published section is moved out from the task, but to keep instead in the workflow level. So when you define and invoke some process, you can decide what you are going to publish as well. It is allow us to have a better control, to have better modules that are more composable because this information is not bound to the module itself. So we can reuse better. And then what about Nextflow limitation? There are many. Nextflow has been created as a DSL, that means a domain-specific language on top of an existing programming language, specifically Groovy. And because this was easy to extend, so give us all the power of programming language, but also allow to adapt to new use cases, to the use cases of creation of workflow. The problem that along the time became some sort of kind of technical debt because it was fast at the beginning, but at the same time, the lack of formal grammar and the syntax parser make it very difficult to detect the error there in your pipeline. The scripts are too fragile. It's difficult to report clear error message when something is going wrong. Also because behind the scene, it's quite impossible to really understand where the problem is. So how we want to solve this? The idea here is to evolve Nextflow into a first-class programming language. How to do that? Well, essentially, adding, creating, and defining a well-defined grammar syntax parsers. Along with this, then we can have also real static type checking so that when you are running your pipeline, the system type checker can also check a lot of things and prevent the execution if something wrong in your code. Also a better support, better experience for developer having IDE with the syntax highlighting, code suggestion, code navigation, like any other programming language like Java, Go, Python, whatever. And so this is why today we are introducing the language server, a visual code integration for Nextflow. That is what is delivering this experience. For this reason, I want to call Ben on stage. We give you a demo about this technology.
Howdy, folks. My name is Ben Sherman, and I've been working on Nextflow for a few years now, so you've probably seen me on Slack or GitHub. If you haven't, you will. And I've basically been backing up Paolo's brain into my own, at least as far as Nextflow is concerned. And I think I'm almost done, so if Paolo can just stay alive for a few more months, we'll be okay. So for the past year in particular, I've been working on something very special just for all of you. And so let's get into it. So right here, in keeping with Paolo's tradition, I've pulled up his RNA-seq toy pipeline. And so I've opened it, and you notice once you open a Nextflow file or a config file, you'll see this down here, initializing workspace. It's pretty quick in this case, because this pipeline's pretty small. For larger pipelines, it might take a little bit longer. And you'll notice immediately we have errors. Now, the most important thing probably that I want to say about the language server is that it's quite a bit more strict than what Nextflow does. So it's probably going to give you a lot more errors than Nextflow would. Just because you get an error from the language server doesn't mean that your pipeline will fail. But the key thing here is that the language server is implementing a sort of a strict version of DSL2. So it's no longer just Groovy plus some other things. It's actually a formal language with a formal grammar. One of the first things you'll probably see is that things like processes and workflows are not allowed to be mixed with arbitrary code, like this log statement. And so if I hover over this, you'll see, okay, these things can't be mixed. I'll move it into a process or workflow. In this case, this is just the introductory log that we want to do when the pipeline starts. So what we can do is just move that into the entry workflow, and then you'll see now it's happy. One of the other things you'll start to see is that hover hints are everywhere. So you can just start hovering over things, and you'll start to see hover hints for all kinds of different things. You'll see for functions and for variables, for things like channel factories, processes in particular. So here's the RNA-seq workflow. It's a sub-workflow that's being used here. And so in this case, you're seeing just the inputs and the outputs. So you can very quickly see, okay, what does the interface look like? Again, here's one for multi-QC. So you can again see inputs, outputs. And by the way, if I forget, an argument here, then the language server will complain saying, hey, this process has 2 inputs, but you only gave me 1, right? So that's nice. And the funny thing about this is that as I've implemented this, I've discovered things in VS Code that I didn't know even existed. So it turns out that if I control click on this thing, it'll take me right to the definition. And then I think on Mac it's alt click. So you don't have to go in here and try and remember where the file was or search or whatever. You just click on it and it takes you right there. And so here's our RNA-seq sub workflow. We can see a few more processes in here. And let's go into FastQC. And so in the process, again, there's hover hints everywhere. So we can hover over a directive and you get a brief description of what that directive does. And if you want more details, I can click read more. And hopefully you trust our website, so it'll take you there. So you don't have to go into the docs and search for it manually. It'll take you right to it. But most of the time, hopefully, this description is all you need just to get a quick idea of what's going on, right? And then same thing for input types, output types, things of that sort. Let's go back to our main workflow here and see what else we can show off. Okay, so we've got some params, and if I hover over a param, it's giving me the name and the type. Now, where could that be coming from? Well, it turns out that this pipeline has an NF core parameter schema. So if the language server sees that you have one of these files next to your main script, then it will read it and it will pull all that information. So all the information about the parameters is coming from right here, as you can see. And then in the same fashion, if I make a typo or try to reference a param that isn't in the schema, then it will give me an error around that. And also, if it'll give me auto-completion. If I do params dot, then I can see all the params, and again, you can see the descriptions down here. Moving over to the Nextflow config file, this is probably even more useful because there's hundreds of config options out there, and so same idea, I can hover over a config option and it gives me the information for that option. I can, so if you're in the middle of giving a demo on Wave and you can't remember what the setting was, you can just pull it up, and again, you can see all of the information related to that setting. So there you go. So Nextflow scripts and config files are all both supported. Let me think. One more thing. Because the syntax is a bit more strict, there's probably going to be a little bit of pain as certain little quirks you have to learn how to adapt. So I left a little gift for you, which is that if you do manage to fix all those errors, you'll see this little preview DAG button pop up in front of your workflow. So should I click the button? All right. You click on that, and it'll pull up a little DAG preview to the side. Let's bring this front and center. So this is very similar to the DAG you can get from running Nextflow, but crucially some differences are you don't have to run the pipeline to get it. And you notice I did this for just a sub-workflow. So you could just look at a sub-workflow instead of having to look at the whole pipeline. And it's also a much more condensed. It's about as bare bones as you can get. It's just showing inputs, outputs, and all of the processes and sub-workflows that are in between. You don't see all of the channel and operator boilerplate. So this is a way to get, a very condensed description, a visual of what's going on. All right, that's all I'll show for now. There's a few more maybe housekeeping notes I want to add just about the overall, what we're doing with the language. So like I said, this language server is implementing what I would call our first iteration of the Nextflow language. And so we've added a couple pages to the docs. First, this VS Code docs that just goes over the VS Code extension features, as well as if you go to this section called syntax guide, it goes over a number of things that we've restricted within the language server. And so, some common errors you might run into when you just plop in your DSL2 code, and just some quick ways to fix those. So hopefully that'll help you get into it as quickly as possible. We've also added a syntax reference, which gives a full description of all the syntax that is allowed. So if you were using some obscure Groovy syntax that is not supported anymore, and you're not sure why you're getting a certain error, go into here, you can go in and see what's allowed and see whether or not it includes whatever you're trying to do. And as far as the roadmap, I would say overall, there's a lot of moving pieces going on here, but for now, the language server is a completely separate thing from Nextflow itself. It can't hurt you. All it can do is complain. It can't stop you from running your pipelines. So for now, you can think of it as sort of an optional linter. Over time, we're going to incorporate it into Nextflow itself so that the CLI is at parity with the language server in terms of error checking. And that's going to allow us to do a lot of nice things like adding a linting, formatting, just basic error checking to the Nextflow CLI. So say if you have CI for your pipeline release, you can have that error checking built in, improving things like the inspect command to getting the full list of all the containers in your pipeline. And then moving forward, like I said, this is the first iteration of the Nextflow language. And so from here, we can evolve Nextflow into its own language and when we want to add new features like static types or record types, we can do that our own way. the Nextflow way, rather than just something that happens to fit into the Groovy syntax. And so with that, I'll leave you all to play with it. Your editor is waiting. Thank you.
Awesome. They changed forever the developer experience for Nextflow developers. Okay, let's close this presentation talking a bit about Fusion, that is our technology for storage and Nextflow pipelines. And why we need a special file system for Nextflow pipeline could be a question. It's because storage is the bottleneck for data pipelines. The problem is not computing power. We have access to a lot of computing, but the problem is to have an efficient way to transfer, to access, to upload the data that is produced by this pipeline that is huge. This is the main problem. And there are a lot of solutions out there. The problem is that or are extremely expensive, especially if you work on the cloud, or they do not fit well the use cases deployment into the cloud. The ideal solution would be to use object storage like S3 because they are cheap, relatively cheap, and also scale very well. The problem is that there is a mismatch between the interface or the tool that we use in the pipeline that use POSIX file system, they just use file essentially, with the API of the object storage that are just HTTP API, very simple. So here is where comes Fusion, that they create basically an adaptation layer between the tool and the object storage, make it possible for the tool to work natively with the object storage like S3, with storage, observable storage, like if they were a native file system, local or shared file system. And also, it provides an optimized model to access, to move the data between the bucket and the container where the job is running to optimize the access to the data, essentially. And the key is this smart caching algorithm that uses the local disk to speed up all the I/O, the operation with the data that is stored remotely. Also, now, another beautiful thing that you need to manage an external service or another file system or another piece that requires some configuration. This is automatically delivered into the container that runs with your pipeline, just adding a configuration setting to your Nextflow file. Key benefit, so it's faster when compared to other similar solutions or general purpose tool. There are many of these, but we have much better performance because we designed for this use case for Nextflow pipeline. And it's cheaper compared to other shared file systems for cloud like FSx or EFS. And the other big advantage is that you don't run out of space. That is very common when you deploy a pipeline into cloud VM or use a shared file system like FSx because they have limited space, or you allocate a large storage, but you spend a lot of money, or you tend to allocate less, but then you can run out of space. So using these mechanisms that you can scale indefinitely, like S3 essentially, there is no constraint, or at least not a declared one. What's new in the latest version of Nextflow, Fusion 2.4? We work a lot to improve the stability of this system under heavy load. Also, we improve the reliability when using small disks, so there were a lot of little use cases or little problems that were fixed into this version, so to make more reliable. Also, we added support for file attribute, POSIX file attribute, that now can be persisted over S3, so we increase the compatibility of existing tools that need to use this capability over the object storage. Interesting to see the benchmark. It is important to compare how does it work Fusion term performance compared to other solutions. We run NF Core or NSIG, our reference pipeline for this kind of benchmark on AWS Batch using on-demand instances. And comparing with plain S3, FSx, the shared file system by Amazon, and Fusion, you can see that the fast as actually even a bit faster into this benchmark, the FSx Fusion, and twice as fast just using S3. So, and the benefit came from the fact that using Fusion, you don't spend time, compute time to move the data because it's made in a much better way by this caching algorithm that was mentioned before. Also, there is an improvement in cost efficiency. Here, we have reported the cost breaking down by the compute cost, but also the storage cost, because you pay separately for the storage. And here, you see the clear benefit using Fusion compared S3, because there is less compute time, so you spend less. But also compared to FSX, because the compute time more or less similar, but you pay much less the storage. And very similar trend also when using spot instances, actually even more amplified this, because there is less spending for the spot instance, but the component of the storage is bigger. So along with this, also we are working to a next version of this technology, where there are some improvement. One of these was an internal redesign to make it more efficient, to simplify some operation, to make it more extensible. Another important thing that we are working to adding a new caching layer using available memory that there is in the container. So all the key, like I was mentioning on Fusion, is this caching algorithm using the disk, but when a disk is small or slow, you don't have much benefit. Instead, the idea here is to use the RAM to speed up the operation. Also, we designed Fusion to manage large data. It is efficient with large data, but it turns out that genomics pipeline can have also the need to manage many small files. Many small files is a typical headache for many file systems, also for Fusion to some extent, and there were tasks that was a bit slow using when there was this situation. So in this version, we improve a lot of the performance when handling or creating many small files. Here there is a benchmark comparing Fusion 2.4 with the 2.5 alpha. In 3 different scenario pipelines, synthetic pipeline creating 1,000 files, 5,000 files, 10,000 files, there is a clear benefit in all these scenarios. So it's improving a lot also for, not just for big files, but also for small files. And okay, 3 minutes. I have one more thing that is somehow apparently unrelated to storage and Fusion, is the problem when we come using spot instances. Spot instances is the provisioning model that more or less all cloud providers have to provide cheap computation, but with the caveat they can interrupt the virtual machine at any point in time because they relocate for another job, another customer, or whatever. And what's the problem? The problem is that this model is the one that we want to use because it allows us to have much more efficient computation from cost point of view, but it works well if you have small jobs in your pipeline. The reality is that genomics pipeline are very large job, takes hours. So usually what happens, your pipeline use spot instances, they get interrupted, and so Nextflow, what is doing? Restarting the task. Most of the time this works, the second time you have some chance this get executed, and with a few reinterruption restart, you get pipeline completed, even though what is happening in some cases when there is low availability of specific instance type, or maybe there is a huge request for spot instances, your pipeline just get restart the task, and then crash again, restart the task, crash again, restart the task, crash, and then pipeline fail, you burn just a lot of money for nothing. How to solve this? Some people, what they do is to essentially try to use the spot instance that is interrupted, and then you can use Nextflow to switch to another queue that use on-demand instances. This works, but it's not the most efficient way to handle this. What it could be done instead is that when there is the interruption, we take the state of the computation, we save into a file, and then when the job restarts, we continue. And this is exactly what we are introducing today with Fusion snapshotting. So essentially, so the idea is that, like I was mentioning, Nextflow will launch a job execution with AWS Batch. AWS Batch allocate an EC2 instance, and with a job container that run your task and Fusion. At some point, it may be interrupted, but what is happening then Fusion detect the event, take a snapshot of the computation, the process tree that is running within the container, so save it into a file, and then when the job restarts, we continue. So basically, the computation continues from the point where it was interrupted. So Using this technology, essentially, you don't have to care about the interruption because in any case, the pipeline progress, whatever is happening. And this is really a game changer, changing technology for our pipeline when using Spot instances. Currently, this technology is available as private preview for AWS Cloud. We are planning to add the support for also Google Cloud and Azure Cloud in upcoming releases. If you want to know more about this, there is this link on the QR code. You can find more information here. So, in conclusion, 3 main highlights of this presentation. Wave container allow to manage the container in your data pipelines. We are adding new capability to scan for security vulnerability your container automatically during your pipeline execution. Nextflow is evolving into first-class programming language, starting using having ID integration with Visual Code. And finally, Fusion snapshotting allows you to use in the best way Spot instance for Nextflow pipeline. Thanks a lot for your attention. Let me say thank you, everybody working this project, Nextflow team, Web team, Fusion team, side dev, design team. Thank you.